Hi, Debabrata once again, and I would not waste my time by introducing myself. The everything will be available in the detailed section of this class. So let me quickly jump into the topic. Today I'm gonna choose the topic like for loop applications. So we have already done two parts of the for loop, that is for series and for patterns. So today I'll be taking on the for loop applications, and this is going to be the most important chapter in your programming career, I would say, because if you are good at for loop, we have already started for loop. So if you are good at for loop, you will be good at programming. If you are not good at for loop, I can clearly say the programming will be tough for you then, simply. And if you are able to understand the for loop programs, then I think it is quite good. Okay. So today's chapter will be most important. So you have to be very careful on that. So practice all those things I am showing. So you can see in the rest of the chapters like array, matrix, how much we use for loop on those chapters. So after a few classes you will be able to understand the importance of the for loop itself, because everywhere it is for loop only. So now, as a prerequisite, I can say if you have a basic knowledge in for loop, that's okay. And if you know something more than that, like if you know how to write a program for prime number, how to write a program for getting factorials, getting HCF, so I will just request you to format everything. Just forget everything and check from the beginning once again. And the second requirement will be it is not a prerequisite, but yeah, you have to have some time in your hand so that you can practice. At least this chapter is very important, so you have to practice all of those things. So today we are not going to learn anything new. We are not going to learn anything new, because whatever we have done for loop, those techniques I'll be using just to show some of the real-time applications. So that's why the chapter name is for applications. So whatever we know already we have done, I will try to apply that on some realistic problem, like some mathematical problems, some normal real-time problems. I'll be applying that. So as we do not have anything much to learn today, I will just show you application. So let's do some experiments. So first, till the date, we have done all the programs in our online platform. So today we can shift into some other software. So whatever you have, you might have Turbo C, you might have anything. Just let me know if you have some software and you are not able to run the programs in those software. So I have Dev C with me for the time being. I can run program in Turbo C as well. So just what you need to do first, you need to create a file in any software. You can also mention the name of the software and look and feel of the software and paste a screenshot in the comment section. I can answer. Okay, so first thing is that you need to do, first you need to print something like hi or hello. That is the most important thing. So here, to print hi and hello, I have to go through in this way. So I just need to print a hi or hello. If I can print a hi, that means it is working fine. At least I need to understand if it is working fine or not. So every program has its own structure in each compiler. So sometimes it require void, sometimes it require int. So I have written the int and I have written one. In the similar way I used to do in the online platforms. So let me first check if it is working at all or not. Okay, I need to save that someone. Suppose for application, let me give some name of this file. Let me first check if it is working or not, if it is printing high or not. Uh, yeah, it is printing high. That means it is working fine and I can write my own program. So I can do two experiments today, because there is nothing to learn more in today's class. So just the application. So that is the first thing. I have tried my own compiler today for the very first time in your class. And the second thing I'm planning to do, like I'm planning to do the programs like this, but using while loop. Okay, so that is my plan. First, let me print this program 25850. So let's learn a new thing today. After that, obviously, we will check some application, because today's class will be easier. But importance wise, it is the most important class. So 258 till 50. how can I print that? So first, obviously, int I have to take, and after that, I equals to 2, I less than equals to 50, and I equals to I plus 3. So if I just try to print, so print percentage t space, I do not need to print it into separate lines, just print I. So if I run, it will print 25811 kind of that series until 50. So we have done a more complicated series, so it would be the easiest one for you. Now if you can remember, in the for series class at the very beginning, I have told you to write something in the first part of for loop, or to write that thing out before the for loop. It is same, you can write it here, or you can write before the starting of for loop. Both are same. If you can remember, we have done that in the very first class of for loop series. So that was the easiest thing to understand. If you write something at the end of for loop, and if you paste the same thing at the end of the for loop body, that will be going to be the same thing. If I run that, it will again print the same series 25811 till 50. So the same thing. So for and while loop. So this is being called as a broken for loop in our language. Means we have termed that as broken for loop in the first class of for loop series. It was the easiest one, and we have learned that in the first class itself. If you forget, just revise a bit, you can understand. So it is the same thing. Either you can write here in this place, or you can write before the for loop. Either you can write at the end, or you can write and as a last line of the for loop body. So both are same. This is being called as a broken for loop. And if you are already confident on the broken for loop, so I can say you have done with the while loop. So broken for loop and while loop are basically same. So just you need to make two changes. Instead of for, you need to write while and just remove the semicolons. So a broken for loop and a while loop are same. If you find any differences, where broken for loop and while loop are not behaving same, or they are printing something different in C, just let me know. I can give you a guarantee, like those are same. If they are behaving differently, just paste the program in the chat box. Like, okay, you have mentioned like broken for loop and while are same, exactly same you have mentioned, but now I can see in this program, like I'm not able to write this program, it is not behaving same. Just in any case, just paste that program into the comment section. But I can guarantee, do not need to take any extra pressure due to while loop, because at the end of the day, for loop and while loop are same. Just you need to put the first part out of the loop before the loop, last part as the last line of the loop, and you are done. That uh, you already derived into the while loop. Okay, so for loop to while loop conversion is very easy. Okay, so now just for giving some confidence, because I have seen many people are saying, okay, I can do the program in for loop, but I cannot do the program in while loop. I really, I do not understand what is the difference between for loop and while loop. So just to give you some confidence, I can do some more programs like 1, 2, 3 till 10, and they are looking for some. So first, let me do this program in for loop, and after that, obviously, I will do that in while loop. So let me do that first in for loop. So it will be for I equals to 1, I less than equals to 10, I equals to I plus 1. So if you, okay, 1 plus 2 plus 3 till 10. So what I need to do, I need to take a sum variable. So again, it is a 3-step rule. Again, I generally challenge few things in my offline classes or the direct classes, where I challenge, like, if you find any differences in this the 3-step rule. If you can remember, we have done to check the sum of any series. So if you find any difference between for and while, so those challenges I generally take. The first challenge is, show me an exception for series 3-step rule, whatever I have told. Show me an exception in for application, while and for loop. So even I'm doing the same for you as well. So if you get any differences, just let me know in the comment section. So let me print the sum here. So 1 plus 2 plus 3 plus till 10, it will be something, I don't know, 51 or something. Okay, 55. Yeah, I'm not that good in mathematics. So yeah, it is 55 and it is printing fine. So as per the rule, I have told you, first part outside of the loop, the last part as a last line of the loop body. And now you can run this for loop as well. It is not like you have to turn it into while loop always. It will also run this broken part. So if you are able to convert the for loop into this broken for loop, then you are done. So just need to remove the semicolon, and instead of for, you need to write while, and that's all. That's all. If I go further, you can also write do while part. So you just need to copy this part. You just need to write do here, and you just need to paste while at the end. So do while has some extra advantages that I will probably tell you in some other classes, because otherwise you will be too much focused on that part. My intention is not to show you these unimportant topics. These are not important. I'm saying the important part will be when I will show you some important application of for loop. But yeah, it is just I'm showing this just to give you some confidence. That's all. That while, do while, basically everything is same. So you can see it is printing the same program. Just you need to write while at the end with a semicolon, and instead of while, you just need to write do. Again, you can try any programs we have done with for loop. You can try to convert any program, any for loop program into while or do while. If it is not working, just paste the code. So enter a number and print its factorial. So if it is the program, so I can do like, I can put some variables like this. I can put like f equals to 1. I can put like printf, enter a number, slash n, and take that number input into n. And what I will do, f equals to 1. And first let me do that with for loop. And after that, I can convert that into any of the loops. So I equals to 1, I less than equals to n, I equals to I plus 1. And obviously f equals to f into I. So now let me print the factorial is percentage %d, and I will print the value of f. I guess we are done. So let me run first using for loop. If it is working, then I will convert that into while loop. So suppose let me give 5, it should return 120, and yes, it is returning. You can see in my screen. So let me convert that into first broken for loop. I can simply copy that part here. I can simply copy that part here as a last line. Let me run this program once again with the broken for loop. And I can give something like 6, and it should return 720, I guess. Yeah, 720. Yeah. So now if this broken for loop is working, so obviously while loop should also working. If I remove just semicolons and if I run the while loop, it should also work. Okay, so if I give 7, I don't know what will be the answer. Okay, 5040. Yeah. So you can see it is working. That means it is proved like while loop and for loop are same. Okay. So again, I've not waste much time here. These are pretty much okay. I have done 3 programs just to give you some confidence. So my focus will be today on to, okay, we have another program, 1248. Okay, let me do that quickly and jump into the next topic. Okay. So here, okay, let me do that directly in the using while loop itself. Okay, there is no need to do the for loop programming, then while loop. It is not that important. If anyone says like for loop and while loops are different, just say him or her like, okay, give me an example. Simply give me an example. So let me do that. 1248. Okay, it is multiplying by 2 and until 200. So okay, I can write something until 200. I will print. Let me delete all this. It will not be required. Let me put the printf statement in between the for loop. So I'm just going to print the value of I, and each time the value will be like I equals to I into 2. So obviously you can write the equivalent program in for loop as well. So I will be starting from 1. You can see it is printing in a good way. Okay. So 1, 2, 4, 8, 16, 32, kind of that. So you can see if you want to do that in for loop, obviously at the first line, it will be I equals to 1. Then semicolon I less than equals to 200. Then semicolon I equals to I into 2. Pretty much simple for you. Okay. So I hope you have the confidence now. If not, if still not, let me know why. Okay. So if I jump into the most important part that I have intention to show you, that is the for loop applications, where I can apply the for loops. There is nothing more to know about for loop. For loops are normal, but we need to check multiple applications. And I have segregated those topics into 4 parts. So as a first part, I wish to go into the extract digit part. So what is extract digit? It is something like if someone is asking, like, enter a number and print the sum of digits. Like, as an example, so suppose if you have given 153 and they want the sum of digit, like they need 1 plus 5 plus 3. So that is equals to 1 plus 5 plus 3 equals to 9. So we have a nice approach to solve this program. So to solve this real-time need. It is much needed in real time, sometimes, not sometimes, many times, like you need to, it is needed to fetch the numbers, fetch the digits from a whole number. So suppose, let me start with, suppose n is 153 and you need to extract the digits first. So how to extract the digits? Let me write our conventional for loop. So for I will be starting from n. It will iterate until it becomes 0. And every time it will be doing like I equals to I by 10. And if you print, if you just print I percentage 10 every time, I percentage 10, it will print all the digits separately. What does it mean? So let me show you the dry run first. If I start from here, I equals to n. I equals to n means the value of I will become 153. Now I is greater than 0. Yes, 153 is greater than 0. So proceed. So printf, it is trying to print I percentage 10. So we have done the first chapter of this C classes. So if I divide 153 by 10, what will be the remainder? What will be the remainder at the end? So it will be 3. So I'm printing 3 in the screen. So we are extracting digits from the end. So if I extract 153 or if I extract 351, both are same. We are basically extracting the digits. So we got our 3 at the very first. So now it is saying, as a last line, it is saying I equals to I by 10. So 153 by 10. So 153, I equals to I by 10. So 153 by 10. So 153 by 10 means it will become 15.3. But as I is integer, it cannot hold that 0.3. So it will become 15. So next iteration, it will become 15. Now, 15 is greater than 0. Yes, 15 is greater than 0. That means I will go inside the loop once again, and 15 percentage 10. 15 percentage 10 means if you divide 15 with 10, obviously the remainder will come as 5. Okay. So 15 percentage 10, so it will be 5. Now at the end, it will be like 50, I equals to I by 10 means the current value of I is 15. The next value of I will be 15 by 10. That will be 1.5. So again, I is an integer. You can see, obviously integer means it can only hold the whole number. It cannot hold any fractional value. So 0.5 will be deleted and I will become 1. I will become 1. Okay. So again, 1 is greater than 0. Yes. So it will go inside the loop and it will be like 1 percentage 10. So if you divide 1 with 10, the remainder will always come as 1. So I am going to print that. And the next term, I equals to, again, the same thing. I equals to I by 10. So I by 10 means 1 by 10, it will become 0.1. So again, I is integer, so it cannot hold any fractional values. So in integer, it will be 0. So now this time I is not greater than 0. I became 0 itself. So the loop will be stopped here. And if I run, we can get 3, 5, and 1 in this manner. We are getting the digits, but not in the like in the forward way. It will be in backward way, 3, 5, and 1. And it is the famous way to extract the digits from a number. So here we are not doing anything new. We have just seen a new application of for loop. So the for loop means it is not required that we will always do plus and into. We will not always do sum and products. We can divide it, we can subtract, we can do anything, we can put any conditions here. I will try to show you how much means what are the different scenarios where we can use the for loop more efficiently. So there is nothing new to learn. It is just about the application where I can use the for loop more efficiently. So you can see what I'm doing. Every time I'm printing percentage 10, and every time I'm doing by 10. Again, I got some new number, and then again percentage 10, the last digit I am fetching. And after that, I equals to I by 10. I'm just removing the last digit. So if you do not get the idea what I have explained, I will request you just pause the class. And if possible, just rewind this last 5 or 6 minutes. I have given the example. So just go through that once again. Still, if you are not able to understand, just let me know in the comment section. Okay. So that is the way to fetch the digits. So we have used the conventional for loops, but with some tricks in for loop. Okay. So that you need to know when to apply what. So now in the next program, if it is asking, it is a very famous program, if the number is Armstrong number of or not. What is Armstrong number? So obviously in your question paper everywhere the definitions will be given. You do not need to remember like what is Armstrong number, what is Debabrata number, what is Guha number, anything it is given, ABC number, anything, they will explain, okay, what they are trying to mean. So now Armstrong number means the cube of the digits, the sum of the cube of the digits will be that number itself. If you do something like 1 cube plus 5 cube plus 3 cube, that means 1 cube means 1, 5 cube means 125, and 3 cube means, I'm not that good in mathematics, but I guess it is 27. So if you sum them up, it will be 153 once again. So that is why it is being called as an Armstrong number. So if you want to get the Armstrong number, so if you just need to print like, okay, if the number given is Armstrong number or not, what do you need to do? Okay, the last program I have not done yet. I guess it was asking for sum of the digits. Okay, first let me do the sum of the digits, then I'm coming to this program. So sum of digit, again, the 3-step rule, you just need to introduce sum equals to 0 at the end. You just need to print the sum at the end. And inside, obviously, whatever you are printing, we are printing I percentage 10. So whatever we are printing as per the 3-step rule, we just need to put them inside the sum. So sum of digit is done. Okay. So if I run, you can see, oh, 9, I guess, 1 plus 5 plus 3. Yes, it is printing 9. You can see in my output screen. So now you can also do something like you can first put the digit into some variable. You can simply put I percentage 10, that is digit actually. And after that, sum that digit. So anything is accepted. You can do anything. If I run again, so 153 will return 9. So that's the thing. Okay. So now if I want to take a variable input, then how it will look like? Again, it is the same thing. We are just playing with some outfits of the program. The main core part is done. So I can enter a number. I can give a prompt to the user, and user is going to insert some values inside. So let me delete that constant value, and I hope that part will also work. If I enter anything, let me enter first anything. Suppose enter a number. I can write 725. Say, so it will be 14. 5 plus 7, 12, and 2, yeah, 14. Okay, so you can run any type of, you can give any type of number and you can extract the sum of digits. So now if it is asking for Armstrong number, so in Armstrong number, obviously, we just need to do d to the power 3. So we can implement that using, or I can simply write d into d into d. Okay, so the cube. So now if I execute, so enter number 153. So it will obviously return 153. So that is the gist. Now if I run, like, okay, if the sum equals to the original number, that is n, I'm just going to print, like, okay, it is Armstrong number. Percentage d is Armstrong number. So the definition might be changed in other programs, in your exams, in your viva. Suppose it might change, the definition might change, but do not worry. You just need to respond as per the definitions. Okay. So I have worked on this Armstrong number on the basis of a definition, like Armstrong is a number for which the sum of the cube of digit equals to that original number. So that number is going to be the Armstrong number. So definition might change in your case, but you need to answer that accordingly. So I can write percentage d is not an Armstrong number. If it is not, sum equals to n. So let me run this program. Let me give some input like 370. And it is saying, yeah, 370 is Armstrong number. So it is what? It is also an Armstrong number. You can check mathematically. 3 cube plus 7 cube plus 0 cube equals to 370 itself. So as 371 as well. 371 is also an Armstrong number. You can just try to do that mathematics in your copy. Okay, but if I enter something like 372, so it is not an Armstrong number. Okay, so there are many hidden Armstrong number there in our number series. So anyway, we know how to fetch a digit and how to solve some real-time requirements. So now, as a last program of this topic one, like enter a number and print its reverse. So it is going to be the same thing, kind of the same thing. So let me first take a variable called, not sum this time, let me put something called r as a reverse. So I will extract each digit, and what I'm going to do, after extracting each digit, I will just going to do r equals to r into 10 plus d. And I can write the reverse is percentage d, and I'm going to print the value of r itself. So what I'm doing, if I show you the dry code, if I show you the soft run, so 153, obviously it is going to fetch 3, 5, and 1 in reverse order. You need to have a good idea on that. We are fetching the digits from the backward, not from the forward. So first digit will come as 3. So what I'm going to do, the first value of r is 0. So what I'm doing here, r equals to r into 10 plus d. Just listen carefully. So that means the old value of r, that is 0, into 10 plus the digit I got first. So that is 3. So r equals to 0 into 10 plus 3. It means I'm not that good in mathematics, but still 0 into 10, 0. 0 plus 3 means 3. So the value of r is 3 for the time being. Next turn, it is saying r into 3 means r equals to r into 10 plus digit. So next turn, already we have the value 3 inside r. So it will be 3 into 10, that is 30. And digit will come as 5 next turn if I go from backward. So 30 in plus 5, that will become 3, 5. So now next turn, it will be like again r into 10, the existing value of r into 10 plus the digit. It is equals to plus 1. So that means 350 plus 1, and that becomes 351. You can see. So I got the reverse of the original number, and that is the way you need to think. So that this kind of thought is complicated, I admit. Again, if you are understanding what I'm doing, that will be enough for this class. You do not need to try all those programs to solve by yourself. We have a pretty nice exercise for this class. After the class, you can go through that. If you are not able to do, I can share the solutions as well. But you are getting the feel of this chapter. You do not have anything new to learn. We already know for loop. We are just checking the different application in for loop, and that is going to help us to get a job, because in the job interviews in everywhere, they're asking for the logic. They do not check how much you know. They know, like, okay, the for loop concept is very small. It is not requiring many things, but you need to understand where we can apply those for loop efficiently. So that is important. So that's what I am trying to show you in this class. Okay, so there is nothing new in the for loops, but we are trying to form the for loop in many different way to solve the requirements. So here we are fetching the reverse of a number, and that is quite important program and quite uh, useful programs in our upcoming journey. Okay, so if I go to the slide, and if I move to the topic 2, so it is like mathematical problems. Mathematical problems like enter two numbers and find its HCF. If someone is asking that, find the HCF. So if you can remember, we have done the HCF in our class 6 or 7, what I can remember. So if I try to do that, suppose we have two numbers, 60. My digital handwriting is not that good, so you can excuse me for that. So, but still, if anyone is asking for the HCF of 60 and 30, so 36, what will we do in our copy? We will simply divide 60 with 36. The answer will come as 1. It is a pure mathematical thing. I'm not good in mathematics, and even I'm not your mathematics teacher. So I hope you are understanding this. If not, I will just request you to go through some mathematical problems once again and just check what you have done earlier. So here I got the remainder as 24 because 60 is not divisible by 36. So we will keep doing this until a number is divisible by another. So 60 is not divisible by 36. So the remainder comes at 24, and I'm trying to divide 36 again with 24 this time. So obviously 36 again is not divisible by 24. So I will continue this process. So I will get the remainder as 12. Obviously it is mathematical. I hope you are able to understand that, because I cannot explain more of the mathematical topics. But still I'm trying my best. So if you are able to understand, then that is very good. It was our mathematical process that we have learned in our class 6 or 7, what you can remember, in our school days. So you can see now 24 is divisible by 12. That's why we generally indicate like 12 is our HCF, because it is the last part where we can divide, because we can divide 24 by 12. That means 12 is going to the answer. So that's the thing we need to do here as well. So here we can first take two numbers from it as input from the user. So first number, suppose it is going to be X, and next number will be Y. So let me take those numbers first, and then I'm coming to the program, the main logic. So enter first number, enter second number, enter X and enter Y. That is fine. Now I will iterate this for loop in some different way today. So what can be the way? So I will iterate this loop until X is divisible by Y. So until it is not divisible, I will keep doing this part again and again and again. So whenever X is divisible by Y, I can simply go at the end, because for loop will be ended. I can simply say the HCF is Y. If any of the X is divisible by Y, I can say like Y is the answer. But in middle, if X is not divisible by Y, suppose let me mark them, which one is X, which one is Y. If you can remember, the first X is this one, 60. And first Y is, let's take some example. X is 60, Y is 36. 60 is not divisible by 36. You can see it is clearly written. If it is not divisible by Y, then it will enter into the loop. And it will do something like in Z equals to X percentage Y. So we can take Z outside, means we can initialize Z here as well, like comma Z. But the use of Z is very temporary. So we can declare that inside the loop, and it will just help to store the value like 24. So it is Z. Okay. Because 60% is 36. That is, remember, we have learned that in our first class itself. First class in C. So Z equals to X percentage Y, and that will be 24. So the next turn, what I will do, Y will take the value of Z. The new Y will be 24. New X will be 36. And I will iterate this process once again. So what I will do, in the next turn, X will take the value of Y. X will become 36. And Y will take the value of Z. And Z is 24. So I'm going to do the same thing using 36 and 24. So the new X is 36, that is the older value of Y, and new Y is Z, that is the 24, that was X percentage Y. So every time I'm doing the same. Again, in the next turn, you can see the green values. 36 is not divisible by 24. So what I'm going to do? Z equals to X percentage Y, 36 percentage 24, that is 12. So X will take the value of Y. The previous value of Y was 24. And Y will take the value of Z. That is 12. We have just derived that just few seconds ago. So Y will take the value of Z and X will take the value of Y. So now 24 is divisible by 12. Answer is yes. It is not equals to 0. It is equals to 0. 24 is divisible by 12. So after the for loop, I can directly print the HCF is 12, the value of Y. So you need to iterate, you need to change the values accordingly. Okay, I have deleted probably something. Okay, no. Let me delete the dry runs. Yeah. So you can see first value of X and Y is 60 and 36. Then X will take the value of Y will take the value of Z. So the next set of values will be 36 and 24. And next set of values is 24 and 12 until they are divisible. So now 24 is divisible by 12 and I'm printing directly the value of Y. If I enter something like 60 and 30, which is divisible in the first turn itself, because in the first turn itself, 60 is divisible by 30. So it will not going inside the for loop. It is simply printing 30 as a result. So it will simply print HCF is 30. It is not going to enter into the for loop body. Okay, so 60 and 30, if it is divisible, I can simply print HCF is 30. That's all. Okay, in case of any doubt, you can let me know. So now if anyone is asking like, okay, let me delete these drawings. If anyone is asking like LCM, so again, it is a mathematical process. We are solving the mathematical problems. So if anyone is asking for the LCM, so we know the multiplication of two numbers equals to HCF into LCM. If I can do that program like X into Y equals to HCF into LCM. So that means LCM equals to, okay, let me write in this way. LCM into HCF equals to X into Y. So I can, if I want to extract LCM, so just it will be like X into Y by H. It is again a simple mathematics. If you're not able to understand this, I do not have anything to do because it is a mathematics we have learned in our school days. So LCM is just like multiplication product of two numbers divided by its HCF. So first we need to store the value of product. So int p equals to X into Y. Because we are losing the value of X and Y, the value of X and Y is changing. So it is better to put that at first inside some variable. So at the end, what I will do, my task is not now to print LCM, HCF. I'm just going to print LCM. So it will be something like, as per the mathematics, product by HCF. If I do that, it will extract the LCM. Let me run the program. Okay, I'm doing probably something wrong. What I'm doing wrong? H was not defined in the scope. Yes, obviously, sorry, it will be Y. If I execute, yeah, obviously. After giving that example, I thought H was there. Okay. So now if I give something like, again, the 60 and 36, I don't know what are the LCM. Okay, it will be something like 180. Yeah. It is the lowest common multiple. It is the lowest number like 120 by which I can divide it by 60. I can divide it 36 even. So 360 also is a number that I can divide with 60 and 36. But again, it is LCM means the lowest one. So 180 is the lowest one by which means 180 is a number which can be divisible by 60. Even that can be divisible by 36 as well. So it is LCM. I'm not a mathematical teacher, and I'm not going to I shouldn't comment more about the definitions of LCM. I hope you are more means you are stronger than me, at least in case of mathematics. So you know what is LCM. So this is the mathematical approach to derive LCM using our C language. Okay, and you can give some tough programs to computer as well. He will solve that for you. Okay, so now if I go to topic 2, enter two numbers and find its LCM, but without using HCF. So it is saying like you cannot use HCF now. So what can be the logic if I take something like 40 and 30? Or even I can take 60 and 36 as well, but let me change the number. So here the lowest common multiple will be 120 because 120 can be divisible by 40 as well as 120 can be divisible by 30. So 120 is a number that can be divisible by 40 and 30 both, and that is the lowest one. So what I will do, instead of checking, I have seen many tasks from my direct students. So they have incremented that by 1. So they first divide 40, then go to 41, they go to 42. So first you need to think any logic, good or bad, you need to think on that. If you got some logic by yourself, that is good. If not, let me show you the best logic that we can use here. So first I'm going to divide 40 with 30. Just check if our number 40 is divided by 30 or not. If not, I will increment that with 40. So that will be 180. If 80 is divisible by 30 or not, just let me check. No. So I will again increment this number by 40. So next number will be 120. 120 is divisible by 30. Answer is yes. And 120 is the answer. So I will check all the multiples of 40. 40, 80, 120, 160, 200, 240, kind of that. Among this number, whichever first will be divisible by 30, that is going to be our answer. So 40, 80, 120, 160, 200, all the multiples of 40, let me check if they are divisible by 30 or not. So among these, only 120 is divisible by 30. And that's why 120 will become the answer. So what I'm going to do is very easy, very easy. So I'm just going to take any number out of that. I will be starting from X. It can be started with Y as well. If it starts from Y, I'm going to check all the multiples of 30, means 30, 60, 90, 120, 150, 180. Among these, whichever is the first one that is divisible by 40 will be the answer. So if I go to the series of 30, is it divisible by 40? No. Is it? No. Is it? No. Is it divisible by 40? Yes. So 120 will be answer. So you can start with any number, the bigger one or the lesser one. You have to start with any number. So I'm starting with X. It will go until the value of I is greater than X into Y or something like that. And I will increment that every time equals to I plus X. Every time it will be incremented by X itself. And why X into Y? You can give any number because we know any number, the LCM, the maximum LCM will be X into Y. X into Y. Like 5 and 7, all these things are mathematical. If anyone wants to get the LCM of 5 and 7, so that means the LCM will be 35 because 5 into 7 is 35. So I'm doing the same thing, I less than X into Y. If you do not like, you can give anything. Let it be an infinite series itself. Okay, you can give anything. But for a good mathematical representation, I can write this here. So anyway, so I equals to X, I less than X into Y, I equals to I plus X. So whenever the I is divisible by the other number, means I'm doing the series of X. So if it is divisible by Y anytime, I can print F like LCM is percentage D, and it will be filled up by I. Okay. So if I execute, if I enter 40 and 30, it should print multiple numbers like 120, like 240, many things. You can see LCM is 120, LCM is 240, LCM is 360, LCM is 480. So if you want to break that at the very starting, you just need to use break. Just use the statement break. So that means on the first go, it will end the loop. It will not going to print the next numbers. So you can see LCM is 120 because it break the loop on the very first time. Okay. So what is the use of break now? What is the use of break now? If I delete everything and if I run simply I equals to 1, I less than equals to 5, I equals to I plus 1. And if I print the value of I, it will obviously print 1, 2, 3, 4, 5. It is quite normal. A very small thing, it will print 1, 2, 3, 4, 5. And now if I introduce something called break, if I equals to 3, just break. That means whenever the value of I equals to 3, it will break the entire loop. It will break the closest loop. So closest loop is this one. We have only one loop though. So it will break that loop. So the loop will be ended. Only 1 and 2 will be printed because at the time of 3, it was just broken. So it is not like our program of that broken for loop, but as per application, we are just breaking the loop. So if I execute, it will print 1 and 2 because when it was 3, it was broken. The for loop was broken. That is the thing. Okay. So that's the use of okay. If I go to our original program of LCM, so it looks like that. And you can use any of the conditions and it will start from X. It will iterate, it will increment it by X, means 40, then plus 40, 80, then again plus 40, 120, then again plus 40, 160. Whenever it will divide it by Y at the first time, whenever it will be divided by 30, I'm just going to print the value of I, and that is going to be 120. And after that, I'm putting a break so that the loop will be broken and no further numbers will be printed like 240, like 360, which are also divisible by both of the numbers. So that will be our approach. So we are just left with our two more topics, and those are very easy. So topic 3 is handling multiple variables. So if anyone asks like enter 10 numbers and find the maximum number out of that. So now you have to understand how does your brain work. Now, if I tell you 20 numbers right now, and just if I say like I need the maximum one, you just need to type in the comment section the maximum number. So what will be your answer? Let's start. I'm going to tell you 20 numbers, and out of that you need to tell me which one is the maximum one. Okay, so let's start. First number is 70, 70. First number is 70, the 70. Next number is 50, 50. Third number is 20. Fourth number is 40. So what is in your brain? What you are thinking? Which number you have stored in your brain? So always you have stored 70. That was the first number itself. So let me proceed. So the fifth number I want to tell like 25. The sixth number I want to tell like 30. The seventh number I want to tell like 100. Eighth number I want to tell like 60. Ninth number I want to tell like 55. So what is in your brain? If I ask in your brain, just answer that. It will be surely 100. Whatever numbers I have told you, if I tell you like, okay, please repeat whatever the numbers I have told you, you will not be able to tell me whatever the numbers I have told you. Almost 9 to 10 numbers I have already explained. So you cannot tell me all those numbers one by one, but you can tell me efficiently what is the maximum, because you are storing only one value in your memory. That is, previously it was 70, the initial number, and after that it is 100 now. So if I want to do the same thing, we need to explore what our back mind is doing. Okay. So if I do something like I and n and max, three variables, and first I will give a prompt to the user like, okay, enter the numbers. Okay, it is asking for 10 numbers, right? Okay. So I do not need to take n or anything. In numbers, what I will do, I will first write like, okay, enter number, start entering number. So first number I will take input inside max. You have done, back of the mind, you have done the same thing. The 70, you stored it into the max. We are now improved animal in this planet. Our human brain is so much matured, so we are not able to understand how we are thinking in the back of the mind. But when we were child, we used to do this kind of mathematical problems in our class 5, our class 6. We put much effort at that time, but now we all are having some uh, good matured memory, and you can do that very easily. But at the back of memory, what we are doing, we are storing the first number as max. We are storing the first number as max. And after that, I am taking 9 other numbers from user, and I'm printing the same thing like enter number. So suppose they are entering some number as x and y, suppose something they are entering. And if anyhow this x is greater than max, we are comparing in our mind. If x is greater than max, like 100 was greater than 70, we are putting 100 into the maximum position. That's what we are doing in reality. But yeah, now our brain is matured, we cannot understand what we are doing. We thought like, okay, it is the easiest one. Are we really thinking in this way? My answer is yes. So we are not remembering any single number. We are just entering the first number and putting that inside max, because we have entered 70 and we put that inside max. And after that, 9 times we are entering different numbers and checking if the number is greater than max, max will take that number. That's all. So if I run this program, okay, I will be max. So if I run this program, user will not be able to understand if I'm taking input from here, if I'm taking input from here, or if I'm taking input from here. From outside, user will not be able to understand anything. Okay, so am I doing anything wrong? Okay, I have not introduced X. Let me introduce X and let me execute. So it will be asking for giving 10 numbers. Obviously, like I have told you the 10 numbers. So first number is 70. So that is going to be stored as a max. So next number 55, suppose 50, 60, any of those numbers are not greater than 70. So 7 in max, still 70 is being held. So if I give any other number 20, and now if I put 100, and then if I put 80, so 100 is greater than 70. So now in position of max, we have 100. So obviously 80, uh, 30, 10, or suppose 52, those are not beyond of 100. So 100 is still the maximum one. So if I write something 88, anything, so you can see at the end we will get like max equals to 100, because we are doing the same thing in our brain as well. We are taking the first number 70 as a max, and after that, out of all these number, if some number is greater than max, that number will be considered as max. Okay, so here 100 is greater than 70, so I will put 100 as max here, and that is the logic. So now if I go into the last topic of today, and that is going to be the range, handling the range of values. So if anyone asks, like, find all the prime numbers in between 100 and 200. So obviously, before jumping into this program, first try to fetch out the prime number program. So I will take an input from the user. Of course, we need to take the input from user. So n, and I will put something like p, and the initial value of p will be 0. And if you believe me or not, I have asked the definition of prime number in my classes. 80% result I got, that is incorrect. You can try, you can type the definition of the prime number in the comment section, or if you can write that somewhere. So just pause my class and just write the definition of prime number somewhere. After you write the definition, you can think it in a good way, but whenever I tell you, like, write the definition of the prime number or tell me the definition of the prime number, you tell it in a wrong way. If you cannot believe, if you do not agree with that, I will just say you to write the definition of the prime number somewhere. Just write it. If you are done, just then, otherwise pause the class. If you are done, just resume the class. So the definition, most of the people write like the number which is divisible by 1 and itself is being called as a prime number. And that is a wrong definitions. Each number is divisible by 1 and itself. If you take two numbers, suppose let me take a number like 7 and let me take a number like 9. So 7 is prime and 9 is non-prime, but still both of them are divisible by 1 and itself. 7 is divisible by 1 and 7. 9 is divisible by 1 and 9. So what is the difference between prime number and non-prime number? As per your definition, the number is divisible by 1 and itself is same for prime and non-prime number. So the definition is it is only divisible by 1 and 7. And it is not only divisible by 1 and 9. It is also divisible by 3. So if a number is only divisible by 1 and itself, so you have to add that term only. Then only you can tell it as a prime. If your number is divisible by some other number between 2 to 6 or 2 to n minus 1, then I will say like, okay, it is not a prime. So what will be our approach? We will check from 2 to n minus 1. That thing we will check. If any number in between that is divisible, I will just going to mark that. So it will be n percentage I equals to 0 or not. If any number between 2 to 6, because most of the people give the wrong definition, so we will go into the right direction. We will not going to check 1 and itself because all the numbers are divisible by 1 and itself. We will check from 2 to n minus 1, except 1 and except itself. Okay, we will discard 1, we will discard n. So we are iterating our loop from 2 to n minus 1. If our number n is divisible by any of those values, any of the values of I, we can say like it is a prime number. But we cannot say that here. Okay, sorry, I'm writing it twice. We cannot say that here. We have to wait till the end. I have seen some people write it here. Like if it is divisible, it is non-prime. I have seen many people, almost 40% of students write it here. Like if it is divisible, then it is non-prime. If it is not divisible, it is prime. But it is not a good way. Why? Let me show you why it is not a good way of writing programs. So if I enter 9, so it is not divisible by 2, but it is divisible by 3. But again, it is not divisible by 4. It is not divisible by 5. So every time something will be printed. So 9 is not divisible by 2. That's why it printed prime. 9 is divisible by 3. That's why it printed not prime. 9 is not divisible by 4. That's why it printed prime. 9 is not divisible by 5. That's why it printed prime. So only in case of 3, it printed non-prime, but it should not be the way. It should not be the way to print 9 as prime, non-prime, prime, prime. It is not good. The answer should only come at once. Either it will be prime or not prime. So to identify that thing, what I will do? I will introduce the value of P as 0. If somewhere, if it is divisible by I will mark that as 1 and I will break the loop. Either you can break or you can not break, whatever you want. So I'm just marking it as 1. So now if till the end the value of P becomes 0, then I can say it is prime, and if it becomes 1, then I can say it is non-prime. If it is 1, that means it somehow entered into this if loop, if part. It entered into this if condition. If it has entered into that if condition, that means obviously it is divisible by something. And if it is divisible by something between 2 to n minus 1, that means it is non-prime. And if it is still 0, then I will going to print as a prime. If it becomes 1, then non-prime because it has entered into this part. And if it is, that means it is divisible by I, and that means it is non-prime. And if it is divisible by nothing, none of the number, like 7 is not divisible by any number between 2 to 6. So P will remain as 0 till the end. So till the end, I will check, okay, P is not 1, that means it is still 0. I can say it is prime. So let me first run this program. Suppose let me give 17. 17 is also a prime. You can see it is printing fine. If I give 15 or something like that, that is divisible by 3 and 5 as well. So it should show me non-prime. Yeah, it is showing. So this is the prime number program. So if anyone is asking for a range of some number, so here it is asking for range of prime numbers. So I'm not going to show you the first. Obviously, do not go for the run behind the range. First, type the program by yourself. How to detect a number as a prime or not. If it is done, then just use one single loop. If I can determine n is prime or not for one value of n, I can determine for all the values of n as well. If it can be derived for one number, it can be derived for a set of number as well. Previously, I was taking input of n and I was checking that, but this time I will provide multiple values of n from the outside, and it should work fine as well. Let me delete this entering values thing. I have done it for one n. Now I'm doing it for multiple n. N first, n will be provided as 100. After that, n will be provided as 101. Then n will be provided as 102. Then n will be provided as 103, and accordingly, it will try to fetch all the numbers. So if I compile and run, so it is saying prime, non-prime, prime, non-prime, many things. So I'm not able to understand what it is saying. So I'm going to add something like percentage d is non-prime, comma, that value of m. And again, here, percentage d is prime. And I will fill that by some value of n. So if I execute, so it should show the values now. Okay, you can see 100 is non-prime, 101 is prime, 102 is non-prime, 103 is prime, 104 is non-prime, 105 is non-prime. So I do not want to see the non-prime one. I'm just interested to see the prime one. So let me delete all this. If p equals to 0, I want to see the prime numbers. So I can, if I compile again, I can see, okay, these are the prime numbers. So let me make it together. I can print something like printf, the prime numbers are, I can write something like this, and I can print only different values of n. It is the same thing. I'm just trying to print it in a more good way. I'm not playing with the logic. Okay, sorry, I have done something wrong. Okay, I have done something wrong. I have to write it here at the starting. The prime numbers are, and I'm just going to print the n. Okay, I'm not changing anything in the for loop. The for loop remains same. And you can see it is printing in a good way. The prime numbers are 101, 103, 107. And yeah, just think how much it can take to, means how much it can take for a human to check and print all the prime numbers between 100 to 200. And for computer, it took 7982 seconds only, not even 1 second. For us, it might take several hours. You can try. You can try to fetch 1 to 1000. It might take several days. Okay, you might think it is easy. Just try. Okay, for 1 crore number, it might take a whole lifetime of human. But for computer, it might be few minutes or few hours maximum. A whole lifetime for a human. Okay, so I don't know if you are aware of this thing or not. So we have many things going on surrounding of us. So I was just checking one article recently, and there they have described like Facebook is trying to develop something like something artificial intelligence, some chatbot which can chat with its means by themselves with their own language. If I show you, you can search something like in internet like two chatbots talking Facebook forcefully stopped. So you can check this article. So it is quite available, and believe me, I was really shocked after getting that. You can check some of the news like this. Okay, so they started talking themselves. They invented one. They took one full night. Actually, just go through that article. It was a nice one. Okay, yeah, you can go through that. Facebook shut down robot after they start talking, after they create their own language. They got a whole night to they experimented a full night. So a full night for computers is like few lifetimes, few births of human. So think in that way. So they have invented their own logic of one language. Okay, you can go through that. It will not be good for me to explain all those things in our live classes. So better to go for the slides quickly. So I guess we have done with all the topics. So or any program is still left? I guess no. Topic 4. Yeah, we are done. So we can go to our Facebook group for the exercise, and it is going to be the most important exercise. If you are not able to do anything, just let me know for the solutions. I will provide that. If I go to our group, if I go to media, you will get, if you go to the album section, you will get one album called Coding Exercise Basic. If you go to that, you will get an exercise like, sorry, you will get an exercise like for applications. Yeah, so there is nothing new to learn, just need to go through those once again. Okay, so just need to think about the logic, how to solve. Technically nothing new to learn. Okay, so just need to solve all those things by your logic sense. If you have the common sense, if you believe, if you have the common sense inside you, then you can do that. Okay, just try to solve all of them. So that's all for the day. Yep, if you, in case of any difficulties, any trouble, just let me know in the comment section. Bye.